All right, welcome to The Explainer. Today, we're diving straight into a hard truth that is absolutely shaking up the tech industry right now. It's a massive reality check, and it's fundamentally changing how we approach artificial intelligence. Look, we just have to face facts. Most AI agents out there right now are basically just demoware. They look like pure magic when they're sitting in a perfectly controlled sandbox, but the second they face the unpredictable reality of a real customer, they break, they become massive liabilities. So we are going to tear down that illusion today and look at how these systems are actually built behind the scenes, because right now, way too many of them are constructed like a house of cards.
Okay, let's really dive into this. On one side, you've got your demoware. It's sleek, it's highly controlled, the inputs are perfectly curated, and honestly, it looks amazing. But then you have production, and production is messy, right? It's full of unpredictable real-world data. It's where system hallucinations run wild and where that cool magic trick suddenly turns into a glaring red error screen. Demos make you feel invincible, but they become huge, real-world liabilities the split second they hit an actual user.
And that brings us to a really stark reality. Demos are easy, but production is incredibly hard. If your entire engineering strategy relies on simply writing a quote-unquote better prompt to fix a model's hallucinations, well, I have some bad news. You aren't actually building a product. You're building a fragile illusion. So today, we're moving completely beyond the hype to look at the real architectural reasons why these agents fail. Here's our blueprint for the explainer. We'll cover the demo to production gap, moving beyond prompt engineering, the architecture of reliability, tool routing and orchestration, the silent killers of AI, and finally, how to build truly resilient AI infrastructure. Let's kick things off with section 1. The demo to production gap. We really need to move past the industry's current obsession with simple prompt engineering. I want you to ask yourself a serious question here. Is prompting really enough to prevent high-stakes failures? Just think about it. Can a single paragraph of text instructions truly stop a catastrophic system failure? Can it prevent critical security vulnerabilities when your agent is hit with real-world adversarial inputs? The answer is a resounding no. A prompt is literally just text. It is absolutely not a structural defense. We really have to contrast the marketing hype with actual operational risk. The hype tells us that AI is this magic box that can do literally anything. But the operational reality, especially in high-stakes industries like healthcare or finance, a minor logic error doesn't just look bad. It creates massive, severe legal liabilities. A misrouted document or a hallucinated medical code isn't just a tiny glitch. It is a massive lawsuit waiting to happen. This quote hits the nail on the head. Prompting does not equal architecture. Prompts are absolutely not a substitute for robust software engineering. We have to start treating AI agents as interconnected software components. They need to be engineered, they need to be tested, and they must be secured, just like any other enterprise application, rather than just treated like some parlor trick. That brings us right into section 2, the architecture of reliability. We're going to shift our focus now, moving away from the fragility of the language model itself and zooming in on the absolute necessity of a resilient system architecture around it. Here is a rhetorical challenge for all the tech leaders watching. You wouldn't deploy an enterprise database without a backup, right? That would be crazy. So why on earth would you deploy an autonomous AI agent without a fallback system? What exactly happens when the model inevitably fails to return a valid JSON? Because it will happen. And if you don't have an answer for that, your system simply isn't ready for production. Real reliability requires a multi-layered defense. Think about building this stack from the bottom up. At the very foundation, you need persistent memory to maintain context and statefulness over time. In the middle, you've got guardrails and validation layers to enforce strict business rules. And finally, sitting at the top, you have the agent logic. This reliability stack is exactly how you orchestrate complex goals into smaller, verifiable subtasks. Which leads us perfectly into section 3, tool routing and orchestration. This is where we take that multi-layered architecture we just talked about and bring it to life in the real world. Let's see how this actually builds out across a real-world timeline. So a request is received by the agent. Immediately it goes through guardrail validation, checking if it's safe, checking if it's compliant. Then comes tool routing. Picture a supply chain agent seamlessly checking current inventory against a global SQL database. It doesn't just think about the inventory, it physically routes a specific query to a tool. Finally, it validates that data to produce a final, truly reliable output. To actually make this orchestration work, operators are moving logic to the edge for much faster processing and lower latency, which is huge, especially for IoT data. They're mapping out these complex workflows in a highly structured state machines. And crucially, they are ensuring interoperability across AWS, Azure, and private clouds. This whole setup keeps your agents from being isolated and guarantees that every single workflow can be audited and corrected. But hey, even with great orchestration, things can definitely still go wrong. So let's look at Section 4, the silent killers of AI. We need to pivot to the critical pitfalls that destroy otherwise smart systems right during the build phase. There are 3 silent killers you absolutely must avoid here. Number 1, zero observability. Number 2, a complete lack of data privacy and security. And number 3, over-automation without proper audits. If you let any of these killers sneak into your build phase, you're leaving your autonomous systems wide open to unauthorized access and severe operational failures. Let's talk about that first one. Observability is basically your ability to see the thought process and trace the precise data flow of your agent. If your agent makes a mistake and you cannot open up the logs to trace exactly which tool or prompt caused it, well, you can't fix it, period. Zero observability literally means zero reliability. Furthermore, security is definitely not an afterthought that you just tack on right before launch. And for high-stakes decisions, think complex medical diagnoses or legal document generation, a human in the loop is absolutely mandatory. You simply cannot over-automate away human oversight without accepting terrifying levels of liability. Okay, let's bring it all together now in Section 5, Building Resilient AI Infrastructure. Because the true return on investment in AI doesn't come from a cool demo. It comes from iterative learning, continuous improvement, and rock-solid infrastructure. To actually succeed in production, you have to prioritize system transparency. You must implement robust security protocols from day one and ensure that your agents have true interoperability across your existing tech stack. We really need to stop building fragile demos and start building infrastructure that can seamlessly handle all that messy, unpredictable, real-world data. So the crucial point is this final blueprint right here. These are your 3 non-negotiables for a resilient agent. Number 1, statefulness. Let me be super clear on this. Persistent memory is absolutely mandatory. Number 2, hard guardrails. You need strict code-level validation. And number 3, auditability, meaning clear, transparent decision logs. A truly resilient agent knows its own limits and has a highly defined, pre-programmed path for failure. I want to leave you with a really provocative challenge. Look at the AI projects you're working on right now and honestly ask yourself, if I remove the prompt, would there be any structural logic left? If your answer is no, then you don't actually have an application yet. You have to truly evaluate the structural and engineering depth of your systems. So here is my final call to action for you. I challenge you to map out a concrete fallback system for your most critical AI agent this week. Literally don't wait. Diagram exactly what happens when the model fails. Let's stop settling for magic tricks in a sandbox and start building the robust infrastructure of the future today. What is your fallback system going to look like? Let's get to work.